you know what every single A350-900 in the world right now has in common? All of their main landing gear came from here. This is Safran Landing Systems. We're in Gloucester, England, and we're here to find out what goes into making these main landing gear. Engineering, certification, testing, you name it. I've got on all kinds of safety gear, including some very fancy safety shoes. Aircraft landing gear may not be a part of the aircraft that you think a lot about. It certainly hasn't been for me, but they're actually super specialized, super specific, and important, critical pieces of the aircraft, and they have to take a lot of why can't I talk? No, this is wrong. Don't come any closer to me.
I think abuse is the word I was looking for. Not so hard to say, you'd think. And we are talking a lot. Thousands of landings with many tons of weight being pressed into these things each time. And here is where they make that all possible. This is Safran's global hub for the design, manufacture, assembly, test, and customer support for those A350-900 main landing gear. Put it this way, when landing your A350, which one is more important to not have fail? An engine or your main gear? I think the answer is clear. Safran is one of those companies most passengers never think about, but their work is everywhere. Engines, seats, brakes, avionics, and in this case, landing gear. Here at Safran Landing Systems' Gloucester facility, components arrive from all over the world, but this is where the main landing gear for every Airbus A350-900 is finally assembled, finished, and shipped out to Toulouse to be joined with the aircraft. This gear is designed for a 283-ton aircraft. This is also the largest landing gear that Safran designs, and it's designed to last 12 years between overhauls, or around 14,000 landings. Ultimately, the product is designed to last for 36,000 flight cycles. The centerpiece of what we're seeing today is this so-called Bogie. This is what the axles are fitted through in an incredibly fine-tuned process to ensure maximum durability and reliability.
We make many parts in here, but one of the parts we do make is the A350 Bogie beam. So here is an example of a completed A350 Bogie beam. It is upside down for storage reasons, but this is the anti-stone chip which faces the runway and protects the component from stone chips. So it's a titanium bogie beam. So if you would imagine the landing gear, you've got your big main fitting that comes out of the wing. This goes on the bottom of the main fitting, so you've got a pivot pin there, and the bogie obviously tips and pivots on the bogie pivot pin. And these are the axle bores, so you've got a big axle each end of the bogie with the brakes and the wheels on. Okay, we're just carrying on, yeah? So the first machine in operation on an A350 Bogie is on the 6-spindle droop and Ryan gantry mill. You've got 3 spindles on the front, 3 spindles on the back, so we machine 6 parts at once. So when it comes off that machine, that's pretty much what it looks like. Okay, so you can see all the cutter paths as we've rotary milled and profile milled around the lugs. Once we've completed this machine in operation, the components then go onto single piece flow. They go on their merry way one at a time. You know where Dave is? Okay. You know where Dave is? The component has gone through the 6-spindle. Okay, it's now onto the depot borers. So it basically machines the 2 main bores. And then the next operation, which is what machining up we're doing now, is the offset bores. You want to fire them up, Liam?
Just to make sure it's 10 mil in the front face.
Yeah. So you see the spindle going? So this could... Oh, there he is, Dave! Where have you been?
I've been waiting all day. I've got a toilet.
All right, peeps, how are we doing? All right. So this is a mill turn lathe. This is a WFL. Does a lot of the clever stuff on the component. When the component goes on here, it's got no crossbores or anything in there. So this machine will then come in, machine all the crossbores, all the spot faces, drill all the holes, greasing holes that are needed in the component, and also finish machine all the internal profile of the component. The cutters just come down into that bore. As it's titanium, the cutting speeds are much slower than steel. It's a much more sticky material.
What is this liquid that's getting sprayed everywhere?
So it's basically, we call it suds, but it's basically a coolant. It's an emulsion, so it's a cutting fluid. It's about 8% oil, and the rest is water. Once the machine has been completed on the WFL, it's all done, it then goes onto this Makov high-speed mill. This is a 5-axis machine which will completely profile the outside of the component. So as you can see, this is the sort of finish we're getting off the Makov high-speed mill, and the surface finish is good enough for flight. And that's the majority of the machining then of the Bogie completed. It would then go on to the CMM to be checked completely dimensionally, and then the final machining op is just the removal of this tooling spigot. We then go on to vibro deburr, NDT, non-destructive testing. The part then just goes across the road for shot peen, then the component back to us for the bushing that I talked about earlier, which we do just across the way there. Put the bushes in, do the bush cutting, final paint, and then it's good to go over to assembly. Obviously it's then important to make sure the component is absolutely perfect and to drawing. So we load the component on there, it will go round and completely check the component that is to drawing, and we haven't got any problems.
One of the most visually impressive parts of this process is where the Bogie is covered in liquid penetrant and then put through a non-destructive testing process to identify any production abnormalities and defects.
We then leave it for a dwell time, which is roughly half an hour to an hour. We then have to wash it off with water. We then run it down this line here, putting it in that tank and then the next one, and then in the oven to dry off. And then we go to the inspection booth where we let it cool down first, and then we spray it with developer and inspect it, looking for any surface anomalies where the penetrant would have been drawn in towards from this bleeding process, I suppose you'd say. See if it's fit for being on a landing gear for a plane. So yeah, this is where we inspect it in the inspection booth, under UV light. We have got UV torch, we go around the whole thing looking for any surface anomalies, and then they should show up light green on the surface. So we inspect the whole part, all around the lugs, all around there, all the way through the bore, if you want to take a look down the bore. So we look all the way through the bore. And that's how we inspect it in this booth, pretty much, yeah.
But the most stunning piece of this manufacturing puzzle has got to be the heating of the metals and subsequent oil quench. This ensures that the metals come out just right for this product, not too brittle and not too malleable and soft either.
the axle of the component. So this is a pretty critical component really in regards to what it does. If this fails, subsequent other parts will fail. So axles are deemed like critical in Safran. It needs to be strong, durable, tough, but can't be too hard because hardness brings brittleness, brittleness brings cracking.
When you look at our product portfolio, we deal with 35,000 aircraft with our equipment fitted to. We deliver over 1,000 deliveries every year. So we fit as a small cog within a huge organisation. But within the UK, we're 5,500 people, Safran are. So we're a big player within the business now.
How do you feel when you sit on an aircraft that has your landing gear?
Pride. Very much so. I'm very proud of this organisation. As I said to you, it's home for me. And whenever we produce these fantastic products, and knowing the effort that goes into making all the individual components across the globe, to bring it all together in one facility and produce this and support the customer for future, what a fantastic position to be in. Yeah. And seeing it on an aircraft and knowing that we did that, it's such a buzz every single time I fly. Being here in 1992, there's a lot of people on this side that recognise me as an ex-apprentice that's come through the organisation. So it's a personal touch that I take an incredible pride in the fact that I'm representing those guys that have looked after me throughout my career.
And this is where everything comes together, moving down the line to become a complete gear, much like what you'd see at an aircraft manufacturing facility, just on a smaller scale.
Welcome in the Gloucester OE assembly shop. So this is a shop where around 130 people work passionately around assembling landing gear. So we are a 24 hours business, 24 hours a day, 7 days a week. We do not stop to build landing gear together. In this shop we assembled Airbus products. So single L, A320 and A321 main landing gear on one side, and the large door landing gear on the other side, which are A330 and A350 main landing gear. We did 100% of the big landing gear, so 100% of A350 and A330, which goes directly to the FAL in Toulouse for Airbus. A big capability to be able to produce those components, those products, with great deal of flexibility. On the Bogie beam, we fit the brakes, so that's very specific because the airliner will decide themselves what type of option they want to fit on the Bogie beam. They can decide what type of brakes, they can decide if they want a tachometer to measure the speed of the wheel. What we're going to be looking at now is what we call the side stair. So on an A350 main landing gear we have 4 side stairs, left and right hand side stair, forward and aft. The main purpose of the side stair is to give structural rigidity to the landing gear, to keep it in place during the landing, taxiing. So you can see here an example on the table. We've got a pair of side stairs. So you can see 4 which are ready. 2 in fact have been inspected and will be fitted on the 834th landing gear that is being produced in this shop.
Safran has an important apprenticeship program here to train and cultivate the next generation of specialist team members from around the area. We saw a number of them around the facility.
No, this looks good. I'm a big fan of Flight Radar 24. So here we see the A350-900 flying right now above Gloucester. All of these aircraft that are flying here have main landing gear that were born here in Gloucester.
Of course, the engineering side of things is very important, and this is a product that is being continually refined and improved over time. We were given very rare access to the testing facility where they put these parts through their paces to make sure they can withstand the incredible amount of forces they encounter every day.
This is an example of a rig that's used for production support from time to time. It's also used for demonstrating and validating, particularly in this instance, updated maintenance procedures on wings, so how we service the aircraft. Typically, as we've said before, we're talking about gears that can take an aircraft weight of 283 tons. So the scale of it, as we see, got to go above the height of a first-story building, and we're talking about weights in the order of magnitude of several A320s. So you can imagine strength tests where we have to go up to looking at limit and ultimate loads is a significant capability required in terms of the test setup and facilities that we provide here.
Here within the customer support department, we're generating all of the technical documentation that's required to maintain the gears when they go through their overhaul campaign. So every 12 years, the gears need to be removed from the aircraft, sent to a shop, completely disassembled, checks performed on them to make sure they're still airworthy, and then they can go back out and be reinstalled on aircraft. So the documentation for that is created here in Gloucester, and all the spare support as well comes from the Gloucester site.
So all of these landing gears are all from, like, if I now look at the old 350s that are out and about.
That's right, they were
Wow.
all designed, assembled and released from here in Gloucester, UK.
How great is it that you can kind of stalk your work on an app to see what they're up to?
We support the full life cycle of the A350 here in Gloucester. So right from the design at the start, through the manufacturing and the assembly, and then the customer support here in this office.
Do you have a favorite landing gear?
No, you can never, it's like my two daughters, you never have a favourite.
Ah, right, okay, good.
So-
Well, you've got a couple of more kids then here.
It's been an incredible day here at Safran Landing Systems, seeing in depth, just in terms of the A350 main landing gear, what goes into that. Previous to this, I had no idea how much knowledge, detail, processes goes into making these things reliable, durable, and I think most of us had no idea. I'd be curious to know what you thought of what we saw today. What surprised you the most? Thanks for joining us. I'm Gabe Lee for Flight Radar 24. See you next time.